All right. Dakota, any questions? Did you get them all right?
I had trouble with 60 and 63.
60 and 63. All right. Let me throw these up again so that you can check as needed. So you had trouble with 60 and 63. Justin, do you have any trouble with anything before that?
Nope.
Nope.
I only had trouble with 60.
60? All right. Anybody else any issues before that? Be honest.
55.
55. All right. Everybody get 50? No? Didn't you get 50? 50 tends to be a hard one for that one. All right. Let's take a look at a couple of these. So we said 50, 55, 60, and 63. We'll go through a few of them on here. So let's see where we are at. Let me do this. All right. So 50. That is, let me see. Riding your bike gets too dark. You got to get a ride home, correct?
Mm-hmm.
All right. So on most of these, you're going to have something that's got to be the same, either the time or the distance. It will typically be the same one versus the other. I think on the way there, she travels at 16 kilometers per hour, and the way back, it's 80 kilometers per hour, correct?
Yeah.
All right. Is the distances the same, or are they different? Same. Whenever you're going to your friend's house, you're coming back. That distance is going to be the same. So we're going this way. We're going this way. The rates are different, however. The rate for going out is 16, and the rate for coming back is 80. Are the times the same? Are the times the same? Should they be the same? No, if you're going different miles or different rates, they shouldn't be the same. But what do we know about the times? They add up to what? Or do we know anything? 3 hours. So the two times, so I'm going to call T1 plus T2, adds up to 3 hours. And so I'm going to label those different, right? So they're not the same time. Mr. Buckenfield.
Hey, will they be working later?
Yeah.
I can come and explain.
All right. Yeah. Okay, no problem. Perfect. All right, Anna, how'd you do it? Because there's 2 ways you can do this. Both of them work. You said you got this. You're like, no problem. Got it.
I did it very differently.
What? What'd you do? Maybe there's a third way.
I have a different thought process.
Okay.
I don't know why. In my mind, I was just thinking that on the way there, she went. Well, actually, no. I did on the way back. She basically went the 80 miles an hour, and then on the way there, she went 5 times that. Or actually, no. Wait. I went
1/5.
backwards.
So 5 times it would be on the way back.
My equation was basically the time it took there plus 5 times the amount of time equals the 3 hours.
Okay.
And then you just add it together to get the 6 times the amount of time equals the 3 hours, and then you divide it, and then you plug the time back into the 80 kilometers.
Read me your equation. Read me your equation.
T plus 5, T equals 3 hours.
Okay. T plus 5T.
Yeah.
So what you're saying, I see you're saying that this time would take 5 times as long as the first one.
Yeah.
Because the rate is 5 times faster. And you said T plus 5T equals 3 hours.
Yeah.
That gave you 6T equals 3. And that gives you T equals 1/2, right?
Yeah. And then, so it took.
So half an hour.
Yeah. And then you know the rate.
So 16, or that would be, actually T would be there, and then 5T would be here. So then you multiply that.
The 80 kilometers an hour.
Times a half would be 40, and then 16 times 5 times that would be 2.5. All right.
Yeah.
So now there's a third way to do it. That's great. That's great. All right. And I didn't think about that. But anybody do anything? Well, let me just show you mine, and then you can go from there. We know these, and you don't need to change a thing. That's absolutely perfect. We know these add up to 3. So what I'm going to go back here is I'm going to so that T2 the second time has to be 3 minus the first time, right? Whatever it is, if it's an hour, then 3 minus an hour is 2 hours. Has to be true. Can we agree on that? All right, I'm going to let T1 be X. I'm just going to do that just so it's different. I'm going to let that be X. So that means this is going to be X. All right, we know the distances are the same. So now T2, what can I take and how can I rewrite that? So it's 3 minus X, right? So if that's X, my time has to be 3 minus X. Our distances have to be what? Same. So that means 16X has to equal 80 times 3 minus X. And so 16X equals 240 minus 80X. And when I add 80, I get 96X equals 240. And then I get X equals, I believe that's 2.5. So that means that this time is 2.5. This time will be a half. And then just like Anna said, we multiply 16 times 2.5 to get 40. Because this doesn't answer the question, does it? Because it says how far apart are the houses. You can't say 2.5. That has to do with time. Okay. So, and that would be, so in the end, distance equals 40. Okay. Anybody do it that way? Oh, we got a 0. All right. The other way I did this is we know T1 plus T2 has to equal 3. So 2 times. So if I go back here and I call this, let me just keep that as X. So if I call that T1, that means distance equals 16 times T1. T1 equals distance divided by 16. Here, distance equals 80 times T2. And if I get T2 by itself, it's D divided by 80. T1 plus T2 has to equal 3. So I can say D over 16 plus D over 80 has to equal 3. How do I solve that? I want to wipe out the fractions. What can I multiply by? Multiply by 80 will work. And if I do that, 80, 80, and 80, that gives me 5D plus D equals 240. 6D equals 240. And this way I can get my distance directly. D equals 40 kilometers. Anybody do it that way? All right. Okay. So it all depends on how you look at things. So in that case here, the 2 times have to add up to 3. Take T1 is D over 16. T2 is D over 80. All right, good. So that was 50. What else did we say? We said 55. All right, the sorting letter machine. One machine takes twice as long. Once you see the scenario, T over A plus T over B equals 1. That's going to be like a work rate problem. 8 hours represents what in this case? Time that they both took. And they say one is greater than the other. One is twice as fast as the other. So I'm going to do 8 here, 8 here. And I know they're twice as fast, but I don't know what. So just let one of them be X and let the other one be 2X. Okay, so that would be twice as long as the other one. All right, now some of you may have gotten here and then got bogged down in the fractions. I'm going to get rid of the fractions. What can I multiply by? 2X. Multiply by 2X. So I'm going to multiply by 2X, 2X, and 2X. And that gives me, all right, that cancels and I get 2 times 8 is 16 plus those cancel gives me 8. And then don't forget to multiply over here, that side. Sometimes you forget that. So I get 24 equals 2X. Divide by 2, X equals 12. Well, one of them's going to be 12, one's going to be 24. Which one do they ask for in the answer? The new letter sorter, which would be the quicker one. That one would be 12. Okay, the old one would be 24. It took twice as long. Okay, so that's 55. And now the last two are what, 60 and 63? Okay, shoot them both.
I got 60.
You got 60?
Yeah.
All All right, you need to be 62.
No.
All right, too late. All right, we'll set them both up. We'll set them both up, and then I'll let you solve them from there. So 60, we got chicory. Anybody ever drink coffee with chicory? Or whatever it is? I don't think I've ever even heard of it. But we know how to blend it. 35%. Here, basically, you can do the chart. That is fine, but I'm just going to do equations. For whatever the first blend is, plus the second blend equals the final mixture. It's always going to be percent times amount, because that's going to give us how much pure alcohol or pure orange juice or pure chicory you have. So in the first blend is 35%. Do we know what do we know the 500 is applied to? Is it 500? Which one?
The total mix.
Total mix is 500 kilograms, right? So I know the final mix needs to be, is it 18%?
Yeah.
18% times 500. I know the first amount is 35%, and I know the second amount is 15%. But how much is the amount? So they got to add up to 500. So 200, 300, 100, 400, but we don't know. Label one of them X. What's the other one going to be? 500 minus X. Okay, so 0.35X plus 15 times 500 minus X. Okay? Now you can solve that from there. I'm going to leave that alone. If you didn't get it, finish it. You could put the X here and make this 500 minus X. It doesn't matter which one's which. Okay, some people get hung up on that. So 63. Same idea. You got boric acid though. The pharmacist needs 20% boric acid. How much? 60% must be added to 7.5 liters of an 8% solution to get the desired strength. So you're going to be given a different amount each time. So the 500 in the first problem referred to the final amount. Do we know the final amount for this one? Nope, we don't. But what we do know we're going to add 20%. No, that's what we need. We're going to add 60% and 8%. Do we know how much 60%? No. So make this 0.6 times X plus 0.08. Do we know how much 8%? 7.5. Now make sure you that's 7.5 equals the final amount needs to be 20%, or the final percentage is 20%. What's going to be the final amount?
7.5 plus X?
7.5 plus X, or you reverse that around, either way. 7.5. You got to add the two cases together. Here's the difference. If you're given the final amount, you're going to have one be X and one be 500 minus that. If you're given one of the two amounts that you're combining, then you got to add the X to it. So that's going to be the difference, okay, for that. So make sure you're good there. All right, I'm going to take I want you to be able to solve these, okay, even better. So we're going to take another day, and we're going to keep working through here. Now, if you work through those, all right, if you still struggled a little bit, do these. And here's your rule. You got to try all of them. If you get stuck on one, you go to the next one. Okay, maybe you'll come back to it. Okay, if you breeze through those, then you need to do either one of these two. Okay, you need to do some of the harder problems. Okay, if you got them all right the first time, then hop down here. And then like some of these are the same as you did. So like, you already did, which one did you already do? 45, you already did 45. 58, you already did 58, but do the other ones. And try, you don't necessarily need to go through all of them. Okay, if you did did anybody do the hard one yesterday? All right, so if you did the hard one yesterday, you're going to do this one here. Got it? All I'm asking is you try each one. If you got stuck on any of the hard ones, let me know. If you didn't get your book covered, we'll also do that today. I got to get Marissa's homeworks recorded, and then if you didn't get a book cover, we'll do that as well. What am I missing? Page 27.
I can't do it. Well, I have my book cover.
Oh, sweet. Oh, that's 88.
Yeah.
Hey, you may work with somebody, absolutely fine, okay? If you need to, let me stop my recording.